Hi everyone, today we are going to go over lesson 28. By the end of this lesson, you will be able to compute interest on certificates of deposit, and you will also be able to compute annual interest and yield of a bond investment. We're going to start off with some key terms. First one is dividend, which is the money earned as a shareholder of a corporation. A bond is a written pledge from a business or government that indicates the holder has lent the issuer money and will be repaid with interest after a certain amount of time. Certificate of deposit, or a CD, is a kind of savings account that requires a specific amount deposited for a specified period of time, which earns a higher interest rate than a regular savings account. So certificate of deposit. So keep in mind, with a CD, you must leave the money on deposit for a specified time. So if you decide to withdraw early, you may be penalized, and that all depends on the bank and all that good stuff. For example, when you open a CD and you tell the bank you want to open it for 5 years, you do not want to withdraw the money before the 5-year period. So to find what the amount is after a certain amount of time, we use original principal times the amount of $1. And this only applies if you are given a table that tells you what the amount of $1 is. If you don't, I'll show you how to calculate it in a bit. So the compound interest is simply the amount, how much you get at the end of the term, minus the original principal, or how much you put in there in the first place. So here's an example. Richard invests $7,650 in a 5-year certificate of deposit, or a CD, that earns interest at an annual rate of 6% compounded daily. It tells you the amount of $1 is 1.3498255. What is the interest earned to the nearest cent? So just to let you know what that really means, is for every $1 you deposit, this is only for 5 years, so keep that in mind. Or 5-year, 6% compounded daily. For every $1 you put in, you are getting back $1.35 basically. But I don't want you to round just yet because it could make a difference. So I want you to use the whole number of $1.34 and some change. All right. So first step, let's find the amount. It's simply just getting the original principal times the amount of $1. So that's really $7,650 because that's how much Richard invested at the beginning. Multiply that by 1.3498255 and you get $10,326.17. So at the end of 5 years, Richard will earn that, or will have an amount of $10,326.17. But we want to find what the interest is. All we do is take the original principal and subtract that from the amount. So in reality, at the end of 5 years, Richard earns an extra $2,676.17. Because it says round to the nearest cent, we just leave it at that. Alright, here's another one. So as you can tell, this one right here does not give you the amount of $1, right? So that means we have to find it. So it will take us a little bit longer, but I do want you to write down these steps. The first thing you want to do is find the rate per period. To find the rate per period, we use the APR, which is in this case the 6%. And we divide it by how many periods per year. And that all depends on how often it is compounded. So in this case, because it says compounded monthly, that means we are compounding it 12 times a year because there are 12 months in a year. So we do that. The rate per period is 0.005 because we have to divide 0.06 by 12. Second step is find the number of periods. How many times are we compounding in the years, right? So we know it is 3 here. It's a 3-year CD, so we multiply 3 times 12 because there are 12 months in a year. That means the bank is compounding this CD 36 times in that 3 years. Step 3 is substitute everything we know into the formula A equals P times 1 plus R to the n power. So keep in mind P stands for principal, so you should have learned this in Unit 2, I believe, Lesson 7 or 8. R represents the rate, N represents the number of period. So as you can tell, I substituted. P is the principal, how much you invested, that's the 8,000. The R is the rate per period, which is the 0.005, and N is the number of periods, which is 36. So now we just use PEMDAS. We do what's inside the parenthesis first, so that is 1.005, just adding it together. Next one is E, which is exponent, so that means 1.005 to the 36 power. Plug that into your calculator and you get this big number. You don't have to round as far as I do, but the further you round the better. So I would recommend 6 decimal places. It does make a difference if it is a fill in the blank answer. If it's multiple choice, they won't really trick you, but keep that in mind. So I have that. Now, next one is multiplication, right? And M. So multiply that together, we get $9,573.44. So that is the amount. So at the end of 3 years, Catherine has that much. However, the question is asking for the amount of interest. So like we did in the previous slide, we just take the amount and subtract the original principal from there. So that's really $9,573.44 minus 8,000. That gives us $1,573.44. So be very careful. If it does not tell you to round, you want to leave the answer as is. If it tells you to round to the nearest dollar or something, be very careful with that. Alright, so the final answer for this question is $1,573.44 after 3 years. Alright, I want you to try one out on your own really quick. Pause the video and then resume it when you are ready. Alright, same thing as before, the previous slide. First step is find the rate per period. Keep in mind, it is compounded quarterly this time. So quarterly means 4 times a year. So we get 0.05, which is the APR right here, divided by 4 because there are 4 quarters in a year. When we do that, we get the rate per period to be 0.0125. Next up, find the number of periods. So there are 4 years this time. Multiply 4 times 4 because there are 4 periods per year. We get 16. So the number of periods is 16 this time. Step 3, substitute it into the formula to find the amount. So we have the principal of 10,000, the rate per period of 0.0125, and the number of periods to be 16. PEMDAS, parenthesis first, we get 1.0125. Exponent next, that's to the 16th power, so so we get 1.2198895. For that, multiply that by 10, we get $12,198.90. Last step, find the amount of interest. So we subtract the original principal from the amount, and we get $2,198.90. So that is the amount of interest after 4 years. Alright, this time we're given a little table. So we want to compare, basically compare the different compounds. Holly can invest $7,000 in a 4-year CD at 5% compounded either monthly or daily. We want to determine the amount at maturity for each investment and then find the difference in amounts. So first step, we can find the amount for the first option, which is the monthly in this example. Right? It says monthly right there. So this is what we did before when they tell you what the amount of a dollar is. This time it doesn't outright tell you. You actually have to look at the table. So we're looking at 5%. So that's the row we look at. And we're looking at the monthly, which is this column right here. So we plug in 1.220895, that's the number right there. Multiply that by the original principal, which is 7,000. That gives you $8,546.27. We do the same thing for the second option, which is the daily option. And this time we're looking at this number right here under daily column. Same thing, 7,000, this time times 1.221386, giving us the amount of $8,549.70. So we find the difference in amount. Second option minus the first, or first minus the second. It all depends, but it's basically the absolute value, so you should have a positive answer no matter what you do. And that means it is a difference of $3.43. What that means is, if you were to choose the daily compounding versus the monthly compounding after 4 years, you get $3.43 more. That's what that means. Alright, I want you to try one out on your own really quick. Pause the video and then resume when you are ready. Alright, so find the first option, or the amount for the first option, which is quarterly. And this time we're looking at the 6.25%, which is that row right there, and we're looking for quarterly, which is the 1.063980. Multiply that by 16,000, that gives us $17,023.68. Find the amount for the second option, which is, I made a mistake, I apologize. I meant to write daily over here, so ignore that. But it says daily. So plug that in. We get $17,031.82. So when we get the difference of the two options, we get $8.14. Again, what that means is after 1 year, because this is a 1-year CD, after 1 year, if you chose daily versus quarterly, you get $8.14 more. bonds. Let's go over bonds. So earlier in the definition part, I told you it is a written pledge that you will be repaid your specified amount of money plus interest. So here's an example of a government bond. So when you invest in a bond, you do not become a part owner of the corporation, like a stock, for example. Instead, when you buy bonds, you are lending money to the corporation or to the government. In return for the loan, the corporation or government pays you interest. So to find the bond cost, you get the face value and you multiply that by the percent. To find the annual interest, you get the face value and you multiply that by the interest rate. And to find the annual yield, you get the annual interest and you divide that by the bond cost. So here's an example. We have a $3,000 savings bond at 95.5, pays 6% interest. We want to find the interest. So keep in mind, a bond price of 90 on $1,000 means the bond sells for 90% of 1,000, which is only $900. So annual interest is simply the face value times the interest rate. That is 3,000 times 6% or 0.06, giving us the annual interest of $180. So the interest on a $3,000 bond is $180. Alright, here's another example. This time we're not looking for the interest, or we are looking for the interest, but we're also looking for the cost of the bond. So the annual interest, same thing as before, we get 500 and we multiply by the percent, which is 7%, and we get the annual interest to be $35. The bond cost is the face value times the percent. We convert the 105 to 1.050. That is $525. So the bond cost, or the cost of the bond, is $525. Alright, I want you to try one out on your own really quick. Pause the video and then resume when you are ready. Alright, interest, face value, times the interest rate, which is 2,500 or 2,500 times 6%, giving us the annual interest of $150. Alright, bond cost, which is the face value times the percent. So really, 98.5 is 0.0985 times 2,500. So the bond cost is $2,462.50. So you see how here I wrote 0.5 because that's math. But when you write your final answer, make sure to add the 0 in there just because we're talking about money. So keep that in mind. And that is all that we have for today. If you have any questions regarding anything we mentioned today, feel free to reach out to me.